My name is Michael Coughlin. I'm from Buttevant in North Cork, and I studied physics in UCC. Most of the meteorites that we find in the world are found in Antarctica. This is because they come in and get trapped in the ice, and they get slowly pushed around and pushed up in these meteorite stranding zones next to rings of mountains. And they're really easy for scientists to find because they're black and everything else is white. So they find an awful lot of them. However, they're not finding anywhere near as many iron ones as they expect. And so we found that these meteorites, the iron meteorites, could be sinking, and there could be a layer of them about 1/2 metre below the Antarctic ice sheet surface. Meteorites can tell us more about the solar system in terms of what's in it and how they're formed. The iron meteorites are particularly valuable because they come from the cores of planets, and particularly the cores of early planets in the solar system that are no longer around. So each meteorite that we find can tell us more about the solar system and the universe around us. Typically you have stony meteorites like this one here, and they just are the normal kind of granite and basalt rock that we know as like planet's crust. And then you have iron meteorites, which is the catch-all term for metallic ones, and they're typically from the core of planets, just like our Earth has an iron core inside it. Once we came up with the idea, we imagined the physics of it, and we wrote that mathematically to see what could happen. And then we did an experiment to test it, whereby we put an iron meteorite and a stony meteorite into a block of ice and irradiated it with a solar simulator. And we found that the iron one sank much faster than the stony meteorite, and also that it sank much further. So this proved our idea. And then we applied the idea to the Antarctic case and the Antarctic variables, and we have found that there should be a layer of iron meteorites about 1/2 metre underneath the surface, and that there should be about 1 meteorite per square kilometre in these areas where scientists find them. So typically a team of scientists, for example from NASA, will go out, they'll overwinter in Antarctica, and then during the summertime, when you have constant sunlight, they'll go out in skidoos, in teams, to these areas where they've found lots of meteorites before, or think that they might find them. And they just go out and look for them on the surface. And typically they find them just by sight, by pinpointing them. And they stand out as dark against the white or clear ice and snow underneath them. They're much harder to see amongst the brown or red rock of the Sahara, for example. As well, any meteorites that scientists find in Antarctica can't be sold, they go directly to science. So this makes it very easy for them to keep and to study. I went to Manchester and found this project to work on, but I originally went to UCC and studied an undergraduate in physics. That gave me the skills to do good science, to do a good experiment, and to crunch the numbers and do the mathematics. But as well, it taught me how to think independently and clearly, and how to formulate my ideas really well.